Hello there and welcome to A2 Maths on Specimen Paper 2, and here we're looking at question 6, an iterative sequence question. So figure 2 shows a sketch of the curve with the equation y equals f of x, where f of x equals x minus 8 ln x. The curve cuts the x-axis at the point A and B and has a maximum turning point at Q as shown in figure 2. Find the x-coordinate of A and the x-coordinate of B. So to answer this question, we just have to look at the function really. F of x is equal to x minus 8 times by ln x. Now when a function hits the x-axis, the y-coordinate of it is equal to 0. So we're looking for when the output gives us 0. And we've got two parts of the function here. We've got 8 minus x and ln x. So what x values will make each of these parts equal to 0? Well, the first one, x needs to equal 8. That will make this bracket equal 0, so therefore the output will be 0. And what value of x makes a ln 0? Well, ln of 1 makes 0. So A is when x equals 1, and B is when x equals 8. So there we are, the coordinates are A, which is 1, 0, and B, which is 8, 0. Right, moving on to part B, show that the x-coordinate of Q can be found by x equals 8 over 1 plus ln x. So, we're going to need to differentiate the function for this. So, expanding the brackets, f of x is equal to 8 ln x minus x ln x. So the first part is just going to be fairly straightforward. The second part will be using the product rule. So it's going to be 8 over x, the differential of the first part, and then the second part is going to be we're going to use the product rule here, differentiate the first part, leave the second part the same, so that's going to be ln x, and then do it the other way around. It's going to be differentiate the ln x, keep x the same, so that's going to be 1. And now we want to find the coordinate of Q. We find the coordinate of Q by the differential being 0. And now we just need to rearrange it into this expression here. So we're going to have x over, so 8 over x equals ln x plus 1. And then times x onto the other side. And then divide by what's in the bracket. So we end up with x equals 8 over 1 plus ln x. Lovely, so there we are. That's the answer to this question here. We've shown what we need to show for part B. Moving on to part C, show that the x-coordinate of Q lies between 3.5 and 3.6. So for the x-coordinate of Q, Q is the stationary point, so we need a differential. So f dash of x equals 8 over x minus ln x minus 1 equals 0. We're looking for this, when we plug in 3.5 and 3.6, for it to go either from negative to positive or from positive to negative. I think it's going to go from positive to negative, just by the look of the graph though. So plugging in 3.5, 8 over 3.5 minus ln of 3.5 minus 1. Let's grab our calculator. Fraction 8 over 3.5 minus ln 3.5 minus 1. That gives us a positive value, 0.033. And then plugging in 3.6, we're expecting this to come out to be a negative value, and then because there's a change of sign and we have a continuous curve, we have a root. So plugging in 3.6, we get, minus 0.06. So as there is a change of sign, f dash of x is continuous, then as the gradient goes from positive to negative, goes from positive to negative, there must be a value alpha in 3.5 to 3.6 such that f dash of alpha equals 0, where alpha is the stationary point. Okay, so there we are. The conclusion, something along those lines. More the better. Moving on to part D, use the iterative formula xn plus 1 equals 8 over 1 plus ln xn, where n is a natural number, with x1 equals 3.5 to find the value of x5 to 4 decimal places. So what you do with this one is just set up your calculator and let the calculator do all the hard work for you. So 3.5, put that in first, that's your starting value, and then put in the equation that you want to use, the iterative formula, but instead of writing 3.5, you're going to write answer button, and the answer button is going to use the answer value, which is currently 3.5, which is what we want it to be. So 8 over 1 plus ln answer, this is going to give us x2, which is equal to 3.5512. Press equals again. You don't need to type it in again, just press equals again and you get x3, which is equal to 3.5285. Press the equals button again and you get x4, which is 3.5385. Press the equals button again and that's our final answer here to 4 decimal places, 3.534. So there we are, that's our answer to D part I. D part I, the coordinate of Q accurate to 2 decimal places. Well, what you need to now do is just spam the equals button, keep on pressing it a bunch of times until the number that's appearing on your calculator doesn't change anymore, and you will end up with this value down here. XQ, we'll call it, is equal to 5.5354 to 2 decimal places. We'll write it out to 2 decimal places, which is 3.54. So there we are, that's the answer to D part II. That was 9 marks in total for that question. Question 6. Let's now move on to question 7.